pile up on the sofa. If it wants me, I'ma send a body order. Leave him. I'm taking big brains. Okay. If there's two ways or two words to sum up this stream, is that why are computers so dumb and why do I have to feel like one thing about doing it live is that you just can't, you know, all the mistakes of this is already going really bad. Anyways, today, yesterday, I was learning how to, like, I've been trying to learn how to, for those who've watched some of my videos, I think you know that I'm trying to become a data scientist, and it's through self taught education. That's basically what I'm trying to do, right? But throughout this journey, if there's anything I've learned is that I might, in fact, not be as dumb as I thought I was. I mean, I am damn, you know. But what I've gotten to notice is this: computers are way dumber than I used to think they were. In fact, during my first algorithm class, anyone who's taken algorithms knows that um, one of the first fundamental rules, like some of the information they give you, like characteristics of a good algorithm, is that it's concise, meaning to say that you have to write out like, you have to, like, be clear with your intentions every step of the way. You know, if you tell me 1 plus 1, I can already intel from that you know if you just give me two numbers, 1 and 1, I can know that I can add these numbers and I have two. I can multiply them. I already have this initiative, but computers lack that very thing that humans, we take it so for granted. So I thought that being a good programmer meant that I had to be very smart, when in reality the key to being a good coder, like if you're coding or programming or whatever, is for you to be able to stoop your levels so low that you can communicate in the language of dumb. Computers are dumb, so you don't have to be smart. You just have to stoop your level down. Are you getting what I'm saying? Is this like understandable? Anyways, today I want to look at something called statistical learning again. I think that's what I looked at in the other stream. And yeah, this is like one of the most interesting books that I've, read and I've been reading. It's really nice. And I only got to find out yesterday that there's actually two versions of the book. The first one is the one that I've been reading, and the second one is like the same book but more detailed. Like, it's so details in terms of the theory. So yeah, anyways, I actually haven't read this since the last time I did the stream. So basically, just to catch up, what we're doing right now is called statistical learning, and I'll actually just be studying. I won't do a lot of revision today, but I talk a lot when I'm studying because it helps me feel like the professor during a lecture and then teaching my dumb students. So this is not possibly, this is in fact the last study session that we'll have until um next year, which is just tomorrow basically. But I've got work and all that other stuff. Yeah. But I want to study right now. Maybe I'll do possibly this is like 3 p.m. right now. I'll probably study until 7, and then after that, I'll just get dressed, eat, and go get rested. You know, a lot of people usually think that, oh, engineering students like, um, you know, always serious, always reading. Like they don't have a life outside of books. That is in fact true. What is also true is also the fact that we actually do get to do stuff, every now and then. This is literally my second time going to the club this year. Yeah, the second or third time. But yeah, so what we're doing right now is simple. let's get started and do a little bit of catching up of what we did in the previous stream. So basically, if you saw the thumbnail, it says you're not bad at coding. Computers are just dumb at learning, which is very true. When you're teaching a computer how to code, it's like you're raising a child. You know, actually, no, that's actually not even right because nothing comes close to what humans are. That's just so surprising. Computers do all the amazing stuff, but at the end of the day, the things that we do effortlessly are things that take a lot of expertise, just for someone to teach, computers how to do that. And I wanted to say something. Yeah. I just found out that teaching AI how to add two numbers is very hard. It's actually like a hard task, you know. I mean, not on a global scale, but like in a general way, as in for someone who's got like basic AI knowledge or maybe intermediate, I'm not sure. But basically, what I'm trying to say right now is that computers are dumb. Every time when we're trying to solve like a problem, always think of it from a perspective of what is this? How can I solve this? When the question I think you should be asking is, instead of how can I solve this, you need to ask yourself to say, how can I, firstly, just understand the problem. When you understand the problem, then you need to ask yourself one thing: how can I write this in a way that is, you know, dumb enough for this dumb thing to understand it? That's basically it. It's not magic. It's not rocket science. It's simple stuff. Very very simple stuff. So, anyways, yeah. So, statistical learning. We're looking at statistical learning. What is statistical learning? Statistical learning is, or refers to the vast set of tools that are used for understanding data. When we're talking about understanding data, we're basically just talking about you have data. Data can be anything. It can be your shopping habits during the month. It can be your like your browsing history. Your web activities. Anything can be data. So what is being meant by it? Statistical learning is a vast set of tools used to understanding data. Like for understanding data, basically means that when you have data, you want to make sense out of it. But humans are smart, but one thing we're very bad at, and computers are very good at, is doing tasks in a reasonable finite amount of time. You know, humans can add numbers up to infinity, but okay, that's a bad example. We can add numbers up to 100,000, but it would take us like a long time, right? But if you give it to a computer, it can add it in a way that it takes very less time, like very little time compared to, how we do it. So basically, it's the same thing with the data. When you have data and you want to understand it, you could basically recreate the patterns that are within the data. I think this is what statisticians do. This is what um, I don't know what else, you know. But this is what statisticians do in other professions where they give in data. Maybe they use Excel to try and understand it. They use some, other languages or softwares out there to understand the data. What they're basically trying to do is you've been given data and I want to make sense out of everything put together. I want to see the relationship between the sellers and the customers. I want to see the relationship between the demography of, how the demography of, you know, uh, how each demographic. Uh, I speak English like very, very rarely. Like, and now after 3 years, um, it feels like I'm getting better. Like I'm literally forgetting how to speak. Like my words, like my vocabulary is just so far right now. But what I'm trying to say, yeah. So we use statistical learning to make sense out of the data that we have. And the data can be anything, as I mentioned. So I won't spend a lot of time on the basics, but I'll just brush through everything and then we'll go into the equations and stuff. So one of the reasons why you might want to, look into the data is because of two reasons. You want to make a prediction, or you want to understand the inference. And these are two terms that are basically, some of the major foundations of you being able to understand everything afterwards. So these are two classes of problems: prediction and inference. Let's start with prediction. What a prediction is basically this. Think of it this way. When you're when you're talking about a prediction, the what's this, the basic idea is simple. You have a data set, or you have some data. All you want to do is understand if uh you have a certain input, you're going to get a certain output. Basically, when you're talking about a prediction, I think it's a quantitative problem. I think it's called a quantitative problem, if I'm not mistaken. But basically, a prediction is basically a situation where you want to create a model where you don't necessarily want to know, how the model arrived at the solution. You just want the model to give you the right solution. And this is useful in many situations. Like if let me think of an example. I think a perfect example is maybe, how how salary is affected by factors like age and like educational background. So for prediction, it can be something like, mm, does someone's age, so we can ask, how does someone's age affect how much they earn? And we can pose a question to say, does someone earn more the older they grow? And once the model says yeah, it's yes. We don't know how. So the model can tell us, it can show us the data to say, yeah, somebody, like people actually do earn a lot more the older they grow up. And basically, that's it. Like, we don't care how it arrives at that answer, but all we want to do is know that that's the correct prediction, right? So when we're talking about inference, on the other hand, this is where you're more interested in not only the solution, but how uh, the solution is obtained, or rather, more specifically, how each input variable contributes to a certain solution that's obtained. So a perfect example of inference is this. Um, when you're how can I say it? A perfect example of inference is this. Let's say you're you're trying to buy a house, and the house is priced at, I don't know, $2 million, and you look at the area. If you're talking about prediction, you look at the area. Is this uh price fair for this house in this area? Yes or no? It's a quantitative uh, what's this way of thinking of it, I guess. Is this house fair in the area that it's in? Yes or no? If no, if you create a model based on prediction, it will tell you based on other houses and so forth. But when you talk about inference, it brings in a lot more features or variables, input variables into the equation. Like, does maybe there's a pool at this house, maybe it has an ocean view, maybe it has. You ask yourself questions. How does the pool affect this price? Like, how does it contribute to the price? And what what you basically understand from this is something that leads to a concept called um, um, the the interpretability and complexity or flexibility trade-off, you know, which basically states that. So if we want to, if we want to create a model for prediction, prediction is basically when we don't care how the model works. We, you might think that we might like go for a model that's uh okay, so let's start it from the back. Let's rewind it. So if you're so yeah, as I mentioned, inference and prediction lead us to a concept called um uh the interpretability and flexibility trade-off, which basically states that the more interpretable a model is, the less flexible it is, you know, and the more flexible a model is, the less interpretable it is. What this basically means is that interpretability, of course, if you look at what we like talked about, if you are looking for inference, you want to understand how your model drives at the other solution. So you might lean more towards an interpretable model if your goal is inference, right? But you might think that just because your goal is inference, then you are going to go for the most interpretable model. Or if your goal is prediction, you might go for the most flexible model. But no, it doesn't always work like that. The problem is there is something called underfitting and overfitting, which is just basically when you pick uh, a model that is too flexible or too interpretable, basically. So when a model is too interpretable, it has high chances of being what's the word again? Of being It has a high chance of underfitting the data, which just basically means that when a model is underfitting or has been underfitted, it just means that it generalizes poorly because it doesn't capture the complex relationships and patterns within the data and therefore making poor predictions, you know. So it just says, for instance, a plus b is equals to c, d plus e is equals to c. Well, that's not always correct, right? I mean, I don't know, this is a poor example, but basically it's like it just makes poor. The more interpretable a model is, it will underfit the data in that it's too simple to capture the complex relationships. You know, think of it, it doesn't make sense. If you have the reason why you're building a model is to understand, is to be able to have a tool that understands and interprets data in a way that you can't do, you know. So you're not, so there are complex relationships within the data. And if you want to understand those, and even though you want to understand how those relationships are, affect the output, you don't necessarily want something that's too interpretable because it lacks the ability to, capture like all the relationship within the data. And another thing is overfitting. Overfitting is the opposite of underfitting, which is just basically, um, you know, when you do the opposite of what I just explained. The model is too complex, therefore, it ends up capturing the noise and the random, patterns of chance within the data such that it poorly generalizes to, unseen data basically. And overfitting basically works like this, which is very common. Which is like it has a higher chance of happening because of the fact that when you're training a model, you're using your training data set, right? You split your data into three sets: train, test, and validate. validation set. When the model is too complex, it kind of captures the relationship within the data, within the training data set, right? And it captures the noise that only exists within the training data set. Therefore, if you give it unseen data, that data contains patterns of chance, which are just basically noise, and they don't make sense. So, of course, it doesn't exist in any data. Therefore, the model will be overfitting, which means that it just only works on the training data. Any other data say it doesn't work. Yeah, so basically, yeah, basically that's how everything works. Um, yeah, I'm taking a picture. Let me look at the picture. hmm So yeah, um, that's what basically is that. So right now, I just want to read through the notes. Let me actually just. Uh, I almost ended my life thinking that I was. Oh, so I'm part of like a team and we're developing this core AI model, and that's what I was working on before the stream. And guess what? I almost shared the window to my IDE, which would have been so bad. Being live is such a risky game, you know. It's like you can. Oh, what did I do? What have I done? What have I done? Mm, lad, now. Basically, what I'm trying to do right now is just read through the notes and uh, just I'll be quiet. I won't be saying anything. So let me just st- start a poll. Like I literally have plans where it's uh like I literally have plans. I was supposed to go out at like 5, not 6, 5, and I realized that I have two places where I have to be, and it's like if I go out now, I will uh I will like I won't have time to study until like the day after tomorrow, which is really bad because you know it's not it's not good. Okay, so let's get started. Why is my screen blank? Okay, so right now I'll just quiet. Right now I'll just be quiet and yeah, right now I'll just be quiet because there's no one who's even watching this. Okay. Oh, fucking hell. No touching, babe. статистических. Wait, I want to try something. Basically, the thing that I've looked at for the past, I don't know how many minutes now, is basically just a recap of stuff that I've studied multiple times. And that's why I only skim through most of the parts. And then the other stuff, I heard the case that I poorly remembered or recalled. Well, what is the biggest takeaway of everything that I've learned right now? What I have learned is that I have ahead of me. And looking at the pace that I'm moving right now, going to be so hard to achieve what I want to achieve. And yeah, that just means that I need to like go way harder than this. So, scientist is one of the. Let me take my glasses off. You drive a cylinder. I remember that guy with the Drake outro. Yeah, basically, so what I want to say is um, becoming a data scientist is really hard. Anything to do with math is hard because of the fact that, you know, when you look at the market, there's only jobs where they're looking for people with PhDs. The minimum is a master's. And when you look at it as someone who's only able to get into this field, you think that it's unfair. when you look at the skills requirement and the qualifications requirement, you think that, oh, this is really unfair. But from the time I decided to become a machine learning person or whatever, a data scientist, I have realized just how much information there is in this field. I have done web developer, It's the first one of the first things that I actually picked up in university, and I could literally look at it. Like, I'll share my GitHub one day maybe, but I could look at a website and clone it, like, without any whatever. Like, I could look at websites and just clone them. Like, it's something that I can look back and say, if there was a time I was actually good at something, web development was that. You know, it's not only with web development, it was always like you have to have an eye for design, and the code is basically kind of repetitive when it comes to maybe uh, what you do with the frameworks in terms of the containers, I don't know, the web development is in a way comprehensive, as in you can learn it to a point where you can have a great chance of knowing how to handle a situation. But that's the difference with data science. Science is like the complete opposite of that. It is so broad. It's too broad. It's too wide. It's it's wide, and the worst part about it is the fact not only are you supporting like everything, like when you're a data scientist person, they expect literally everything, and they don't expect you to know a little about it. It's like you're supposed to be in, you know, in terms of how you know the information and how well you can use it and how well you can explain it. You know, the basic equation, that I learned through this book that I'm right now is y is equals to mx plus b. This equation that I learned in high school, and you just plot a simple graph. You find gradient, and that's it. And this basic idea in data transforms into, you know, this idea where it introduces you to the letter F, and the whole book, maybe the whole field is just about this letter F. You know, so this journey is really hard in the sense that not with web development, it was always like I barely read anything. I created something, I didn't understand it, and I knew a great amount of like theory part, not from reading, but from just the practical aspect of it. But machine learning is like you need to be very good at like programming, and then you're supposed to be very good at. It's like you're supposed to be. I don't even know what to say. Basically, machine learning is like so hard, and it the more I read and get into this field, the more I actually start to understand why the like the barrier to entry like is so high. And honestly, I don't even know how I'm going to like find myself in a position where I will land an intern and actually be able to pass, because it's like statistics, linear programming, algorithms, you name it, a whole lot of things. But I just feel like, so I want to, by the end of 2025, be able to say that I'm a data scientist. Like, I know a lot of things to a point where I'm already applying for jobs. Actually, my plan is to work so hard that by mid 2025, I should move on a little more from reading. Like, not yeah, books are important, but like just I should be at a level where it's like I can build stuff. My programming is comfortable. Like, I know my stuff. Like, I'm comfortable with a lot of things, and it's just building maybe or creating original ideas or something like that. I don't know. I do not know. Machine learning is really hard, yeah. This deep learning stuff. It is really hard. I mean, in as much as it's hard, is it like it is hard? That's what I think is it fun. Like that's the best thing about it because the reason why I dropped web development was because it just didn't give me the challenge that I wanted. You know, when I got into it, I remember I saw my friend. He showed me a website. He cloned the Tesla website, and it was responsive. You know what responsive meant, and I was like, "Ooh, I would like to do that." I went on YouTube and watched a tutorial. Like I went hard. Like I was studying until like maybe 4 5 in the morning for a week, and after that, I got comfortable where I cloned, I think maybe Facebook. At first, it was just static pages, and then afterwards, that's when I was like, I'm comfortable with the basics and I can do a lot. That's when I moved on, and within a month, like really good, like I was decently good, and after that, it's like I can learn it within a few hours, and it's just so easy. I enjoyed it, but I easily like out of it because of the fact that it wasn't giving me much of a challenge, and yeah, But this is like it's challenging me to the point where it's like, am I really cut out for this? High level stuff. Like, am I really smart enough to actually be able to see this through until I'm actually able to land a job? I don't know. I'm going to find, and I'm actually going to start a series. Trying to start a series for the longest time, but then there's been a lot of setbacks. Anyways, let's get back into this study session. forgot that I'm on a live, you know. Life is hard, my friends. Just chilling, bro. I'm not gonna miss one message. Cocaine show. Malignos, malignos. Los dentro radical. На suspense 4 на 4. Наверное, бюджет одна на машину. Selemali. Oh no. Put the feet down, drop bomb on the there's a kind Maybe. Okay, this study session has gotten to a point where it's like I'm so hungry right now, and I need to like make some food. You gotta make every plate of food that you eat because that's the health thing to do. But time is of the essence. Anyways, now that this lecture has gotten to this study session has gotten to you know um into uh, like the mathematical stuff. So the most important thing for a person when they're studying is making sure that they understand the basics. I think that's the most, in fact, it's the only important thing you need to do when you're studying. Understand the basics, which for most people are very boring because, you come from advanced class like discrete mathematics, even those classes start easy. Once they start getting hard, like once the complex stuff comes, that's when you realize that all the time you look down on the basics was, like like was not well spent. I don't know what I'm saying. I think I'm fine. Like, all I'm trying to say is the basics are always boring for me. That's something that I can't deny, like every life is like this is the average, the mean squared error, and I'm like, yeah, squared error, and it's a simple equation. But comes to that simple equation, understanding it and how to use it and which situation you need to use it is a whole different ballgame. It's not that hard. It depends with your problem, honestly. But you can't even understand the problem if you don't even understand. Like you need to understand the problem, but for you to understand how to go about the problem, you need to understand the basic idea of the problem, which is also understanding these tools. So yeah, yeah, that is the thing here. But okay, so let me do a recap of everything that I've been studying in this part. So there is something called assessing model accuracy, which it's just in the right assessing the accuracy of a model. So when you have a model, when you are building a model, you want to know for sure that this model is able to predict, to give an accurate prediction. And what I mean by prediction, I mean, let me just say to give an accurate output, you know, you need to quantify. You need to somehow quantify, you know, um, you need to somehow like quantify the how accurate the prediction is basically, like the output is the predicted output. It's called the prediction, but it might be inference or whatever. I'm not talking about inference or prediction. So how exactly do you measure a model's accuracy? Well, it's easy. Basic idea is this: the three sets that you have, three sets, maybe two, but let's just go with three for now. The first set is the training set, which comprises of the majority of the data, anywhere from 60, I would say, or 70%, maybe 70 to 90% of the data is the training data. And when we're talking about the training data, what we have here is when you're training a model, you have your data, right? And in this data, in the case of supervised, the data is labeled. So we know that this predictor, this feature gives off this out. So when we're training the model on the training data, the model is not coming up with the prediction. The model is in the relationships to be able to understand why how a certain predictor will give a certain versus target, so to say, like an output. And when a model does this, that is when you get new data, since it already trained on the training data, the output in there. the input, right? So it knows that when you have this, it gives this. But how accurate can is that prediction? We need to somehow be able to know how far off the the, the model is from the true value, you know. And this is what leads us to something called assessing the model, measuring the quality of fit, basically. And it says that when it comes to uh, the regression setting, we use this equation, which is basically on the screen. And I wish I could explain it, but no, I'm too hungry. And but basically, the equation is simple. So this equation is called the mean squared error. Mean squared error. What you want to measure here is this. So so he says where f hat of x sub I is a prediction that gives f hat is the prediction that gives I preparation. Yeah, I don't know what I'm saying. I don't know if it's easy for me to explain this right now, but basically, how I can simply quantify this is mean squared error. Basically, you're subtracting the predicted value from the true response. If you get that, a perfect example of this is like right here in this in this in this text. Basically, it says that if you have features, age, ethnicity, I don't know what else, location of a person, you want to predict uh, the you have all these features and you have a data set. You can use these features or this information to predict whether someone not is diabetes, like diabetic. You don't necessarily have the to create a model that can someone whose diabetic status we already know. That just doesn't make sense. So we want to create a model that can predict a new per patient, pa- so to say. So when I start talking like this, I know and I need to eat. This is like I need to eat. Let me eat something. But yeah, so that's basically that. I don't know if there's anything else I can read, but the bias virus trader over 15 classification set. I think the most important uh, concept when it comes to studying is consistency. It doesn't matter how little of something you do every day, but showing up is like so important because it's like you're like showing up is so much better than waiting for the perfect time for you to be fully there. I don't know if it makes sense. When you show up for something, let's say the gym. When I go to the gym, like the many times I'm busy, I've got like a 10-hour shift at work. I come back home and I just go to the gym to show up. And in that context, it's like I'm not there to train or make my muscles big. I'm just showing up. I know how important it is for my consistency for me to go to that place. And because it's like if I don't show up today, I know tomorrow I'll have another excuse. The other day I'll have excuse. But regardless of what happens, if I just try to go, not even trying to gain weight, put on muscle, whatever, just showing up and just being there and, you know, mm, being what I'm doing, it is something that yields so much progress rather to like go to the gym every day, like only when I feel like it, which is so rare, like it's not every day. And something that it's like the same thing applies to studying. School is these notes. I remember when I first started reading this book, I knew every bit of every information that I studied. necessarily like memorizing it, but I understood it. I had references. I was so good with this information, but then I haven't read it in like a month or something. Came back, the information is still there, but it's not fully there. Like I don't remember anything. And then the process of just revising through everything from the start is, I know a lot of people would suggest, just quiz yourself, myself, and it's not fully there. It's not fully there. So right now, I'm just trying to be more consistent with my studying in the sense that I just want to show up regardless of how I'm feeling. Just showing for school, I don't want to show up and just say I'm studying, but at the same page, reading the same sentence, over and over for hours or minutes. No. And actually, the thing is, when I started the same session, I was so fatigued because I slept around 5 c.m. and I woke up at 11. I just wanted to sleep at this process, but I just, I just had to study because I knew I wouldn't get the same chance at night because I was literally like so sleepy, but just pushed through and everything is good. Yeah. So the time is almost 6 p.m. right now, and yeah, exactly 6 p.m. I'm ending stream. So there are a few things that I want to talk about. I want to become a data scientist, and I'm currently pursuing self-taught education, if I look it. And right now, I'm very little progress. At this pace, it would literally take me like 2 or 3 years, to get this done. But I don't have that kind of time. I only have to do this. And unlike something like trying to be a successful YouTuber, you can't quantify that kind of success because it's not up to you. But I feel like data science is something you can quantify to say, in the sense that you can say, in a set period, I want to achieve this and I want to be able to do this. And I think that it's very, and that's what I'm basically trying to do. I have a schedule, I have a roadmap on my wall, and I haven't started using the stuff yet. It's just decorations at this point. But but yeah, the plan is study. The schedule that I created was study from 9 a.m. until 8 p.m. Like 3 subjects per day. After 8 p.m., I would go to the gym, come back from the gym, and then on my personal stuff, like my other stuff. That's kind of primary to learn, but it falls into the maybe secondary to some degree. And that's, I want to become a good editor. Like I want to make documentaries. I want to make good content. So uh, that's basically what I've been trying to do. Um, yeah, and this is the first live that I've done where nobody really shows up at all. Like there's no person at all that showed up. I wouldn't say it's sad. It's not even sad because when I lives, I don't expect anyone to pull up because I don't have that much of an audience. So it's just chilling and kicking it. Yeah, but it would be nice if somebody actually showed up. It would be nice if somebody actually showed up. Yeah. Happy New Year in advance to you guys. Now, right now, I'll play maybe some GTA or maybe I don't know. I'll play some game. I can actually go to the gym. I can actually go to the gym. Ah, yeah. I'll just do the gym. I was supposed to rest today, but I go to the gym. So, anyways, see you and girls.